It changes your cells. So any virus comes out because body contagion. So it's just you will not understand the name for yourself.
Good morning, everyone. Yeah, sorry, I think I had opened up another account. And still continuation with a relative and resultant motion. I'm going to first review with one example, and then I can go for the time of range for guns of a given maybe battleship or cruiser. So an example says at 11:50 a.m., a ship traveling at 40 route 2 kilometers per hour due north 45 degrees east is 120 kilometers northwest of a boat traveling at 50 kilometers per hour due north 30 degrees west, where theta is tan inverse of 3 out of 4. A, find the velocity of the boat relative to the ship. Then B, calculate the shortest distance between the vessels and state the time at which this occurs. So here we have a ship at 11:50 a.m. traveling at 40 route 2 kilometers per hour due north 45 degrees east. So we are going to use both methods here, that is analytical and vectorial, so that we can recap what happened in the earlier lessons. So to start with, we need to identify the direction. This is north. The first ship, you can call it ship 1, or VS, you can call it S to stand for ship. It's traveling at 40 route 2 in the direction north 45 degrees east. So this is the rest of the ship. Then we have a boat which is traveling north 30 degrees west. Actually not 30, but it's north 30 degrees west. So this is theta. This is the velocity of the boat, whereby tan theta we have seen is 3/4, which means that if you resolve, you will have this is 3, this is 4, this is theta, this is 5. So when we resolve horizontally, we shall have, this is supposed to be 50 kilometers per hour. This is supposed to be 40 of root 2. So this would be 50, a negative when you resolve, sine of theta. Then up here it will be 50 cos of theta when you resolve the 50 to the vertical and to the horizontal. So, having identified those ones, the first question says, find the relative velocity of the boat to the ship. The relative velocity of the boat to the ship is the velocity of the boat minus the velocity of the ship. But we said the minus does not necessarily mean subtraction. It rather means reverse the direction of the ship. So the ship was going northeast at 45 degrees. We are going to reverse it to go southwest at 45 degrees. So this is negative velocity of the ship. Then we sketch an appropriate vector triangle that is going to represent the two. I can start with the velocity of the boat, which is going this side. Then I can follow it with the negative velocity of the ship, which is going this way. But the magnitude of this is 40 root 2. Then the magnitude of this one is 50. So the relative velocity will act along this line. Velocity of the ship, of the boat to the ship. So we need to find this angle whereby to find that angle, you discover that ideally it is like this. This is the compass up there. Then this one has come with the theta. Then this one is 45. So the whole of that angle is 45 plus theta. So can you get me what theta is? Theta is tan inverse of 3/4, according to what the question has given. So give me the answer for that. Tan inverse of 3/4 is 30. Please press your calcs. Tan inverse of 3/4 you get?
36.869.
0.887. So when you add these two, you'll attain, when you add those two, you'll attain 36.87 plus 45, you get 81.87. So we can use the cosine rule and get the value of the relative velocity. So the relative velocity of the boat to the ship will be given by 50 squared plus 40 root 2 squared minus 100 times 40, which gives me 4,000 of root 2 cosine of 81.87. When you press the calc, what's the relative velocity of the boat to the ship? And the whole of this is under a square root. For those of us who don't recall where we are getting this from, we are getting this from f squared is equal to b squared plus c squared minus 2bc cosine of the angle A. That is if you're dealing with a triangle. So our A is the relative velocity. The opposite angle is 45 plus theta. So that's how I came up with this relationship. We said we minimize writing the definitions because this is applied math. We apply the mathematics. When you write the definitions, you are writing actually notes. So we minimize writing notes. Someone give me the answer.
70. Answer is 70.
Exactly.
.000
0.0.
Yes, 4 zeros.
Ah, then it's 70. It's okay, you can take it as 70 kilometers per hour. So we need to get also the direction of the relative velocity, call it alpha. So this is sine of alpha divided by 40 root 2 is going to be equal to sine of 81.87 divided by 70. Press your calc and confirm to me what alpha is. Today people are coming in late. Why? Are you still celebrating senior 4 results? Okay.
53.1.
53.13 degrees. So if that is our alpha, that means this is 45. Okay. So with that regard, if that is, we need to get the direction, remember exactly. So let me analyze the direction from here. If I sketch a compass right here, and I sketch the velocity of the boat was going at theta degrees. But this theta degrees was making 36.87. Now, the lower angle between the horizontal and the direction of the boat will make 53.13. But now remember one thing, if this is 53.13, then you have already seen that. You're sure alpha is 53.13?
Yeah, it's 29 point.
Because it was going to be exactly in the west. It's going to be 29 point? 29 point? Alpha.
004.
Guys, confirm alpha. You're saying alpha is?
00. Yes.
Alpha is 29 point?
0042.
004. Okay, 29 degrees. It is okay. Yes, now we can analyze correctly. So if it is 29 degrees, then look here. Because the balance here is 53, the whole of this is 53.13. Yet we want, out of that 53, we want only this direction of the boat to the ship, and this is the direction of the boat. So subtract from 53.13 the balance, subtract of 29. The angle here should be 53.13 minus 29. When you take off 20 from 53, you get 33. When you take off 9, you get 24. You get 24 point what? 24.13. This angle. Isn't it?
Yes.
But remember, it's coming from north, eh? And this angle is already known. This first angle is 36.87. So you can read the direction from north. 36.87 plus 24.13. And that is going to give us 60.9. Actually, it's going to give us 61. So it's north, 61 degrees going where? West. That should be the result. Confirm that with the calc. Members, which alpha angle are you getting? Habiba, which angle did you get? Did you get 53? Or you got 29?
Yes, teacher. I got 53.
How did you get the 53? You press sine 81.87. Have you pressed that? Press that with the calc.
Yes.
Divide by 70.
Yes.
Equals times 40 root 2.
I'm done.
Shift sign.
Mm.
Answer what again?
53.13.
Is your calc in radians or what? Huh?
Jamaica
Sir,
normal.
53.13.
I've pressed that thing many times, and that's the answer I'm getting.
If that is the case, then that means if it is 53. What about the rest? What answers do you get?
53.13.
Okay, then
53.1.
let's take, because it was this was a mock paper. So let's take the 53.13. If you have got 53.13, we can do the analysis of the angle like this. We shall confirm with vectorial approach as well. So you're going to confirm that if you draw a compass to analyze the angles, the theta, which was here, this theta was 36.87. Now 53.13 is actually leading us to west. So it means the relative velocity is acting westwards, meaning the relative velocity of the boat to the ship is tending to west exactly.
Come, let me get this concept.
So no one should worry about that. So the best way you can conclude with the direction, someone should mute. Who is that? Unmuted. Could you please mute? Let me mute you, okay, if you can't mute yourself. So I was saying, if you conclude in this direction, we would say it is coming from north. You count off this 90, add on the next 90 to 180, add on the next 90 to 270. So one can write the bearing as 270 degrees. And we can say that the relative velocity is acting in the direction 270. That is using bearing. If you want to use a compass, you say the relative velocity is acting in the direction west. Yeah? Or you can say it is acting, the relative velocity of the boat to the ship is coming from the east. Coming from the east still means you're going to the west, right? So any of those three conclusions about that angle are fine. The second part says, find the shortest distance. But to find the shortest distance, you should recall some of these things. One, you should know where exactly these two vessels were before. Where was the boat and where was the ship? I always give you the example of a bus and a truck and a small car for your parent, if maybe your parent is bringing you to school. And then you see a small car, a bus moving relative to you. There is a position where the bus is. You can see the bus coming from in front, but there is a time when the bus gets closer to your car. And at that instant, the distance between you and the car and the bus is going to be perpendicular. That would be the shortest distance between the bus and your parent's car. So in this case, you need to first know where the bus was or where the car was. Now, according to our question, it's a vessel or a ship and a boat. We need to know initially where were they. So we are saying the ship, which was traveling at 40 route 2 due north 45 degrees east, is 120 kilometers west, north of west. So northwest is going to be in this direction. If you sketch your compass rightly, this is where northwest is. And now the ship is here, while the boat is down here. The ship is northwest of the boat. That's why the boat is down. But the direction here is 45 degrees. And it is at 120 kilometers away. So for that reason, when I sketch the appropriate vector triangle for this, it will take me to having distance initially as 120 kilometers. But remember, it's relative velocity of the boat to the ship. So we make the boat move along the relative path, what you call the line of the relative velocity. So you make the boat move along the relative path, but it will be moving with the relative velocity at that instant. And in that case, it will move along this line towards the west until a point is reached when the distance between the ship and the boat which has been moving is making 90 degrees with the relative path. So this is the relative path where we have the relative velocity of the boat to the ship. But remember, we said this was going west. So if this is 45, likewise, the angle in here will also be 45. Therefore, the shortest distance is small d, and small d can be got from 120 kilometers. It is opposite to the distance, so it is opposite, which is sine 45. And the answer will give me 120 over root 2, because sine of 45 is 1 over root 2. When you simplify this side, you'll get 120 times root 2 divided by 2. And finally, my answer is 60 root 2, which is the best presentation of the answer. But if you want to get the decimals, then you can say 60 times root 2, which will confirm which result. Someone please still press the calc.
$84.8528.
You get 64 point?
84.
84 point?
8528.
8528 kilometers. Then the aspect of getting time, we need to get the distance along the relative velocity, because time is got from any known distance divided by the corresponding speed or corresponding velocity. So if you already know only the velocity, which is relative, because we make the moving body move with the relative velocity, then go ahead and now say that time can be got from the resolution of 120 cosine of 45 divided by the relative velocity, which is going to be 60 still root 2 divided by the relative velocity was 70. When you press your calc, what answer do you get for time in hours? That is 84.85, that is 12 point something.
One point two,
Which is
1.2.
1.212. 12 what?
2.
122 hours. But remember, I said if the question says at what time, you need to read the clock or the watch. Now they gave us a reference time that it was 11 a.m. So it was at 11:50 a.m. Now we need to convert the time. Already we see we have 1 hour already. And how many minutes? 60 times 0.2122. What result do you attain?
12 minutes or 13 minutes now.
You get 12.1.
0.732.
So which is approximately 13 minutes. So it means you'll get the time as 11:50 plus the 1 hour and 13 minutes. And when you get this added together, we are going to confirm 12. Because this is 60, you divide 63 by 60 to convert to minutes, so which gives you 1, remainder 3. So you're going to be having, you carry 1 more here up. Instead of having 12, you're going to have 13. So the time is going to be 13:03 hours. 13:03 is the same as 1 p.m. and 3 minutes. So it's the same as someone saying 3 minutes after 1 p.m. Okay. So that would be our result. Then briefly, I want to take you through one method of vectorial, if I can introduce the ranges. So that's just still a review of what we have discussed earlier. So some of us who have not been here, who have not been good at solving numbers. Remember, A-level is all about solving numbers. If you don't solve the numbers and you postpone them for the teacher, those are your problems. Yeah. By now, we should all be mature. We should know what we want. Very soon, Senior 6 results are coming out. And your friends put in a lot of time using Zoom classes. So if you do not invest in this time of Zoom classes and really solve to maximum, by the time the exams come up, you'll be having a very big challenge. So let's utilize all the time we have. Have we taken the screenshot already?
Yes, teacher.
Okay, so method 2, I'm going to use vectorial approach. So for vectorial approach, we have one, the velocity of the boat. The velocity of the boat was going northwest at theta degrees. So it means when you resolve, you'll have negative 50 sine of theta, and then in the j direction, it was 50 cos of theta. And then we have the velocity of the ship. Remember to put the vectorial notations. Without them, we don't award you marks. That is according to the NEP standards. So you always put the vectorial notations. You need to resolve this velocity of the ship now. I didn't resolve it in the first case because I was using geometrical method. So this will be 40 root 2 sine 45. And then 40 root 2 cos 45. So we shall have 40 root 2 sine 45 and 40 root 2 cos 45. In actual sense, the ratio of sine 45 and cos 45 is the same. And that ratio is 1 over root 2. So if it's 1 over root 2, this becomes 40 root 2 divided by root 2. Even here, you'll have 40 root 2 divided by root 2. I divide off the root 2, which leaves remainder 1, and this confirms 40 of 40. Then this other one, they had given us tan inverse of theta as 3 out of 4, which confirmed that a right angle triangle would predict 3, 4, and this as theta, and this as 5, whereby sine theta is 3 out of 5, and this will confirm a negativity of 50 times 3 out of 5. Then this is a positivity of 50 times 4 out of 5. Still, when you divide off by 5, confirms the negativity of 25. I mean, a negativity of 10. When you divide 5 by 50, you still confirm a positivity of 10. And this will realize a negative 30. And this will realize a positive 40. So we have simplified our vectors. The relativity of B to S, which is the relative velocity of the boat to the ship, is the velocity of the boat plus the negativity of the velocity of the ship. And this can confirm negative 30, 40, plus a negative 40, 40. So in actual sense, this will give me negativity of 70. This is also negative because of the negativity here, and this will give me 0. This confirms that we're on the right track in method 1. Remember, method 1, it confirmed that it was going west. So the 29 degrees was obviously wrong. So the answer was supposed to be for alpha 53.13. That is why I said I will confirm using method 2, whether actually the angle you've given me is the right one, or it's a little bit wanting. So that's confirmed that. We also confirmed the 70, and the negative 70 confirms that it means it's going west. So we have got everything using the vectorial approach. We have got the magnitude as 70 already. You just say magnitude of the relative velocity of the boat to the ship. The answer is 70 kilometers. Where is it going? West. Period. So the second case is to find shortest distance. Shortest distance, we can use which method? We can use the cross product. You will investigate other methods. The cross product is to get the position initially of the boat to the ship when time is 0, and cross it with the relative velocity of the boat to the ship, and then get the magnitude of those two divided by the magnitude of the relative velocity of the boat to the ship. The cross, if I cross them, get the position initial. Initially, what did they say? They told us that the ship was northwest of the boat. Northwest of the boat, making an angle of 45 right here, and at 120 kilometers away. And I always give you the opportunity to choose. You choose one of them. If this is the boat, this is where the ship is. You choose one of them to be at the reference point, that is at the origin. Yeah? We said now you are choosing one of them to be at the post office. Remember, Ugandan coordinates start with the post office. Ugandan coordinates, that's where the 0 kilometers, 0 miles are. So if Kampala is from, if Jinja is 50 miles away, the 50 miles are measured from the reference origin, reference point, which is the origin of our coordinate system of our country. So some of us who wonder where do these coordinates apply? Where do we get these items put in place? The Ugandan coordinate system originates from the post office. That's where the 0 mile is and the 0 kilometers are. So you just choose either the boat to be at the reference, or you choose the ship to be at the reference. And the reference is always the origin, which is always the origin of the coordinate system, which is supposed to be 0, 0. So according to you, which one do you want to choose? Do you want to choose the ship to be at the origin, or you want the boat to be at the origin?
The ship.
The ship. If the ship is at the origin, then the ship has coordinates 0, 0. Now, if you resolve this distance away, then the boat will be at 120, a negative, because you're heading to west, cos 45, and at 120, sine 45. This is the same as writing negative 120 over root 2 and 120 over root 2. So those are the coordinates. If those are the coordinates, you will get negative 120 over root 2 and 120 over root 2 as our vector bracket, minus the origin, which is 0, 0. The reference will confirm a negativity of 120 over root 2 and positivity of 120 over root 2. With this confirmed, you get negative 60 root 2 and positive 60 root 2. Now, the cross of the relative position with the relative velocity will be got from the determinant of a 3 by 3 matrix of I, negative j and k. Then you have negative 60 root 2, 60 root 2, 0, because we don't have the k direction. Then the relative velocity had negative 70, 0, and another 0 now. Then get this determinant. But those of us who were there last time, we said if they have only 2 coordinate systems, then just choose the last one, which does not exist, which is k, and you'll have negative 60 root 2, 60 root 2, negative 70, 0. And this would be our answer, having the vector k with 70 times 60, that is 442, that is 4200, which is 4,200. So you confirm with the calc, which is a negativity of 4,200, but it is coming from 0 minus 4,200 of root 2. So the magnitude of the relative position with crossed with the relative velocity will confirm the square of this under the square root, which will give us that very term, which is 4200 root 2. Then also get us the relative velocity of the boat to the ship, its magnitude. Its magnitude is 70. We already confirmed that. So finally, the shortest distance is going to be the 4200 root 2, which is the cross out of the 70. When you divide these two, the shortest distance is actually 60 root 2, which is exactly the same answer we got earlier on. Since it has confirmed the truthiness and time is flying so fast, I want to let you proceed and finish the number and also use the various methods of approach to see that you have these numbers sorted. Those of us who have just joined, you'll go and check earlier lessons on relative and resultant velocity on my YouTube channel. Just go and type in Wama Hamza, then look for videos. You like it and subscribe, and then you can find the videos for the earlier lessons so that you can try to follow up. When you get a challenge, you come to my inbox on WhatsApp, and I see how best I can have you sorted. I can either arrange for you a remedial, or I can give you further explanation in case you have a challenge along the way. So please finalize with that number, because I see we have more 30 minutes, and I want to use them to solve an example on ranges of guns. Those of us who intend to become soldiers, who intend to join the army, and you intend to perhaps maybe either join the aviation department for the military, or you intend to join the Navy department. If perhaps you go and maybe Uganda, we don't have a strong military Navy department, which has maybe those vessels like submarines, like the warships. But if you maybe join US and other 5-star countries which have those items, perhaps you can appreciate some of this mathematics, and you can see some of these examples coming ahead. So the aspect of the range of guns, if the enemy is attacking you and is within the range of your guns, they can ask you for how long can he stay in the range of the guns so that you can get him. Or for how long, for what time can he keep in range, depending on what the question intends to ask. So with that note, I want to screen share using another item. So take a screenshot very fast so that I can go to the screenshot using the other. I want to open understanding mechanics on my laptop, then I can screen share that so that the questions, even if you don't write them, you just take a screenshot, then you can have them later. Those of us with a hard copy of the book, don't forget to visit page 192. That's where we can find this work. Sorry, not page 192, page 246. So I'm sharing understanding mechanics. Here we are. So this is my question. I'm also going to take a screenshot because I will need it. I need to write on the other white page, whiteboard, because here the questions are too congested and I can't have a clear display of what I want to explain. So take a screenshot. I also take a screenshot. Those of us who don't have understanding mechanics, I'm taking for you the question. Screenshot, I'm going to send it through shortly. So you can make good use of it using the screenshot I've shared. So do you all have the question with us now? I trust those who are on the group, and you can access your WhatsApp. I've sent the question right there. So it reads: a battleship and a cruiser are initially 16 kilometers apart. Initially 16 kilometers apart, with the battleship on a bearing of north 35 degrees east from the cruiser. The battleship travels at 14 kilometers per hour on a bearing of south 29 degrees east, and the cruiser is at 17 kilometers per hour on a bearing of north 50 degrees east. The guns of the battleship have a range of up to 6 kilometers. Find A, the least distance between the cruiser and the battleship in the subsequent motion. B, the length of time for which the battleship has the cruiser within its range of guns. This is a very sensitive question. We have been doing shortest distance time, but now here comes the range of range. Someone can stay in range to be at the shortest distance. So I can write down my question. We have seen the question as said. Let me use a fresh page. The battleship and the cruiser are initially 16 kilometers apart, with the battleship on a bearing of north, 35 degrees east. This is the battleship, this is the cruiser, on a bearing of north, 35 degrees east. So, not 35 degrees east, so this is 35, and this is 16 kilometers. Then they have gone further and said, the battleship travels at 14 kilometers per hour on a bearing of north of south, 29 degrees east. South, 29 degrees east. This is the velocity of the battleship. Then the cruiser has been started to be going north, 50 degrees east. This is the velocity of the cruiser. The guns of the battleship have a range of up to 6. Find the least velocity in the subsequent motion. Okay, so first of all, I can get the velocity of the cruiser, the battleship. Remember, if they do not state the velocity of the cruiser to the battleship or the relative velocity of the battleship to the cruiser strictly, you choose any you want. So I can start with the cruiser to the battleship, which is the velocity of the cruiser minus the velocity of the battleship. This is going to give me the battleship, its negativity will go this side when sketching. So with that reason, I can have the velocity of the cruiser and the negative velocity of the battleship. Whereby the magnitude of the cruiser is moving at what speed? 17 kilometers per hour. The battleship is moving at what speed? 14 kilometers per hour. So this is 14, this is 17. The relative is going to act along this line. The relative velocity of the cruiser to the battleship. We need to get this angle. Now, because we know that this angle is 29, correspondingly, this is also going to be 29. Then 90 minus 29, that balance is going to be 61. Now, if this is where the cruiser was going at 50, what if I just join this cruiser somewhere here? You will see that this 50, when you draw a compass up here, if this is 50, then this angle is 40. So correspondingly, this is 40 degrees. If that is 40, then this angle is 101 degrees. It means ideally I should have sketched the diagram better, as I'll show you when I'm analyzing the diagram at the end of the day. And we can have this and say the velocity of the cruiser to the battleship is going to be the square root of 14 squared plus 17 squared minus 2 times 14 times 17 cosine of 101. Someone press the calc and get me the answer.
Then 3.9964.
You get?
23.9964.
kilometers per hour. Now, we need to get this direction to confirm exactly where it was going. Call it beta. So that sine of beta divided by 14 is going to be equal to sine of 101 divided by CVB, which is relative velocity of the, which is 23.99615. Someone press the calc and confirm beta. And my dear students, remember, however much they have eased the lockdown, the virus is still there and is still moldering into different variants. So it is a personal one now. You have to be very cautious. My mask is on. It's just that I'm speaking to you right now and I'm isolated, but I don't lose it. I have my sanitizer in my car. So you should also get one, a small one. Sanitize every time it's possible. Or wash hands with soap. Keep your mask on. If people are laughing at you, let them laugh at you. But you should be knowing what you're saving. You're saving your own life. So COVID is still there. It is still existing. So better take serious caution. In case you are to leave home, that is if you have to leave anyway. But you as a scientist, where would you go now? Even Dad is sending you to town, oh mommy, please ask them. Daddy, have a lot of numbers to solve. You have Humphrey, you have understanding mechanics, you have the internet, you have past papers. So you're busy. So there's no need of you, moving around. Remember, COVID does not spread itself, but it's spread by people. So have it in mind. Are we done with the computation?
34.94.
34.94 degrees. Okay. Since we have got an answer, 34.94. Okay. So I'd written that part. We go back to analysis and confirm. If this was going this side, then perhaps to make it 100, it should have been going somewhere around this one, so that I can analyze this in this form. To make this 34.94, then the whole of this one now is 101. Then our relative should be acting somewhere around there, with this as 14, with this as 17. Now, listen to this. We had already seen the relative velocity of the cruiser to the battleship. And this angle was at, if this one is, the 17 was going at 50. So this angle down here was 40. But remember, the whole of this was 50. Now, what is the balance here? Or you say, because this is 34.94, add on 70. It is the angle you're going to sketch up here. So it means the angle is going to be here. It's going to be the whole of this one is 70.94. But if this angle is what? This is 30, this was 35. What angle is here? From the distance, if this is 16, 35 minus 90, the answer is 55. No, 65. So there is a balance of 65 here. But we have seen that the whole of this angle is 74.94. So 74.94 minus 65, the answer is 14.94. That is the remaining angle here. There's a problem with analysis of that angle, please. In case you have a challenge, let me know, and then I can review for you how we have got that angle.
Teacher, I beg your pardon.
Okay, beg my pardon. Let me go back to that again. Let me start from here. Let me sketch a new extract out of this. This is the 17. Eh? The 17 had a 50 here. So the balance down in this way has a what? A 40. Do we confirm that this is 40?
Yes.
Confirm? Yeah. So
Yes.
in that regard, it means there is a balance of 50 up here. But the 17 has been mixed with the relative velocity of the cruiser to the boat. So the relative velocity of the cruiser to the boat has confirmed that the angle between the velocity of the cruiser and the relative velocity, that angle is 34.9. Do you agree? You can see
Yes,
that.
teacher.
Okay, if you can see that, you can also confirm that now the whole of this angle up to down this way, the whole of this angle is going to become 74.94. Is that true? Is that true?
Yes, teacher.
If that is true, now get this angle and come and sketch it with the distance. But as you're sketching with the distance, you're starting from the west, from the east, and then you're going to measure off 74.94. But the distance itself is at what angle? The distance itself is at an angle of 65 from east. Do you agree that the distance is at 65 from east going to north? You can see that 65, right? But because you have measured, because now this is the distance of 16 initially. Now, if this is the 65 it is measuring, we are measuring from east going to where the relative velocity is. This is the line of the relative path of the cruiser to the boat, making an angle of 65 plus 14.94 will give me, will give me 74.94, which is this one we wanted. So because I cannot write it in here, there is a balance which I want in between the relative path and the distance initially, and that balance makes it 14.94. Does that make sense now?
Yes, teacher, thank you.
You're welcome. So we move the cruiser along this path until a point is reached when the cruiser comes and makes 90 degrees with the battleship. Therefore, this becomes the shortest what? Distance. Now, with that reason, the shortest distance D will become the distance, which is 16 sine 14.94 degrees. Press the calculator and confirm the answer. What do we get?
$4.12.
You get?
4.12.
4.12. Exactly. Because remember, in UNEB, we mark for the small places.
0.1249.
1249 kilometers.
49.
Okay.
Yes.
So you have to write up to 4 decimal places, unless they have stated that you can write your answer to 2 dp or to 1 dp or to 0 dps. Now, the next question says, find. What does it say? How long it is in range if the battleship has guns up to a range of 6 kilometers. Now I've drawn a new extract because up there my pen cannot go beyond that height of the whiteboard. If the range of the guns is 6 kilometers, it means there is a point here where the cruiser can be position 1. Let me call this C naught. Okay, this is C naught, the shortest distance. Then there is this point, C double prime. At C prime, the cruiser can be 6 kilometers away. Even here at C double prime, the cruiser can be 6 kilometers away. You know why? That here at C prime, the cruiser has started being in range of the battleship. If the cruiser is the enemy, and this guy is a commanding officer on the battleship, he wants to fire the cruiser. They're asking him, if you miss him the first time, for how long is he going to be in range? Of course, nowadays, they used to have mathematicians used to do those computations, but now computers are there. They estimate those ranges and times. Abda, Aisha, your hand is up. Aisha, is it by accident? So I was saying, pardon?
Teacher.
Yes.
Excuse me, teacher.
Go ahead.
I was saying that you say here, okay, on this last board, the last portion of the board, there is 65 plus 14.94, and you're saying it's 74.94. Then it's supposed to be 79.
Wait, it's supposed to be, let me see. Oh, yes. Oh, then it means if this is 34, 34.94 gives us what? 74.94. Now, 74.94 minus 65, okay, what do you get? You get 9.94.
That's 9 point.
Okay, so change this to 9.94. So this is 9.94. Thank you for that. That's why everyone has to compute with a calc. Even me, I'm not the custodian of computations. If I use my head sometimes, it's just because maybe I want to chase time, but you can also call. That's why I say confirm with the calc, so that you give me the right option. But thank you for that. So when you press the calc, what answer do you get for the shortest distance?
.7619
kilometers. Okay, thank you. Anyone with a hard copy? What is the answer in the hard copy? Because the soft copy takes us longer to open and check, and the time is flying. Now, guys, this is what I wanted to show you. They're asking us for the time in range. They're asking us for the total time between C1 up to C2. Now, what we need to do is to get the distance. The distance here, x1, is the same as the distance here, x1. But that distance, this is, remember, the line of the relative path. The body here moves with the relative velocity. So the time is supposed to be 2x1 divided by the relative velocity of the cargo ship, the battleship. This is how we find the time of range, or the time when someone is in range. They can, sometimes they will not bring a number in terms of guns and battleships. They will bring a number for a boy who can throw a stone. And there is a car passing by. And then they can ask you, for how long is the car in range of the boy hitting it? So they can interpret the question like that. So another person can be a thrower of javelin, shot put, anything they can throw, as you see people throwing many things. But now I can see this is the right angle triangle. Remember, we got perpendicular distance and we have got the shortest distance. So I can find x1. The shortest distance we have got 2.7619. This is 6. I can find x1. Can you get me x1 using Pythagoras theorem? It will give you 36 minus 2.7619 squared under the square root. What answer do we get? Make it snappy because we have 6 minutes left. Economics is on its way, so you have to make it snappy. Meanwhile, you take screenshots. Don't forget that. What answer do you get here? Guys, press your calculators. Maybe some of you are using what? These are the purple calculators. Are they still 5 points?
3, 2, 5.3265.
5.3265 kilometers. Okay. But to find the time, we have said the answer is the total distance from C1 up to C prime. That is the time this guy is in range. So it will be 2 times 5.32165. One should know that this one, I don't know why people have not asked, why is x1 and x2 the same? Okay, divide by the relative velocity, which is got as 23.99615. What answer do you get? What answer do you get?
Teacher,
Yes, please.
the one between 2 and 6 is not there.
The one between 2 and 6 is not there.
Yes.
On A. What is there?
It's 3265.
5.3265. Okay. 3265. Okay. So adjust that and compute and give me the answer. Mr. Gerald is about to get in here and chase us from this stream. So better be fast. I've not seen any questions coming through my box. Are you guys passing all the numbers? And by the way, remember, after the end of this topic, I'm going to give you a test concerning this very topic only, right from vector, from crossing a river, plain in windy conditions, up to relative and shortest distances. I will upload it on the Google Class so that we can get it from there. So I think we should prepare within the next, that is after next week. Guys, answer?
0.4439.
0.4439. These are hours. Can you convert them to minutes so that we can get the right approximate, which is easily readable? Times 60, what do you get? That's approximately 2.24 minutes.
26 point.
That is approximately 26 minutes. Yeah, so what I wanted you to see or to get to know today is about the range. When they ask you to find the range someone can be closest to another, if maybe the other one has a given range of a given distance, then one should understand that if you have got the shortest distance, capital D, I mean small d, then perhaps if the other one is in a range of some distance, maybe y, that distance can also be experienced on this side. And then you find x1 and x1 there. You can even use an isosceles triangle relation and interpret that and solve the number. So this distance, which is here, because this is the line of the relative velocity of the cruiser to the boat, the time can be got from twice x1, what is over VCB, and then you can compute and get the answer. So I'll need to see more of your solutions. If you get a challenge, don't forget to inbox me. And in case of anything, please, for further also knowledge and further discussions, visit my YouTube and do attend and see that you can have at least some of those numbers sorted. If you have your friends of senior 5 or brothers and sisters who have already seen what the combinations they are going to take on, let them know that we have services going on for them. We're going to arrange services for senior 5s and senior 1s. So as we wait for the lockdown to unlock, you never know, it might unlock next year. Before they go green, we need to keep them busy. Okay, my name is still the same. Take care and stay safe. Screenshot, guys. Ajit.
Excuse me, teacher.
Yes, please. You have a question?
Yeah, what's your number?
Hey, you mean you don't have my WhatsApp number? 0782 855 674. Ajit.
Thank you, sir.
No, hey. Mbadde nsomesa naye maliriza. Maliriza.
Yamza. Wako simu.